Hey guys, we're Brittany, Enyuan, Harry, Jules, and Jordan, and today we're going to be looking at wave energy utilization. So, what is wave energy? Wave energy is an emerging renewable technology that harnesses the power of waves to generate electricity. It relies on waves created by wind energy and harnesses their power in a variety of methods. These are largely defined by their location and the method that they derive their power. Wave energy generation can take place on the shoreline, in the nearshore, or offshore. How does it work? Wave energy at its most basic converts the power of wave movement into electricity. Methods of harnessing this power include using the wave to compress a hydraulic ram, spin a hydroelectric turbine, or converting the oscillations of waves into power. Where is it currently in use? Current wave energy projects remain rather small scale. Existing wave energy projects are largely centered in areas of high wave energy potential. As you can see on this map, coastal regions on large oceans such as the Atlantic, Pacific, and Southern offer the greatest energy potential, and so current projects include the UK, US, Portugal, and of course, Australia. We're going to be looking at wave energy within three different aspects: land use, CO2 emissions, and its feasibility in Australia. To start us off, Enyuan will be providing an overview of land use and implications of wave energy, including how it is impacted by location and factors that can affect its usefulness. We'll then hear from Jules, who will be examining the implications of wave energy on CO2 emissions and how wave energy can help address the issue. Finally, Britt and Harry will give us an assessment of the feasibility of wave energy in Australia, including where it might be effective and where it may have environmental impacts. I'll now hand over to Enyuan.
Hello everyone, I'm Enyuan. Next, I will introduce the land use of wave energy. The first step in creating wave power, find the best place to place these energy converters. Not all coastal areas are generating wave energy. The shape of the seabed land changes the size and shape of the waves. Wave energy converters are also expensive. The best position should have enough wave action, but not too much, so as not to damage the converter in the storm. Of course, it is the best to have a lot of people living near the coast. This area may be a good place to make waves. To find the best location, scientists turn to computer models. A computer model called SWAN. The name stands for Simulated Wave Near the Shore. SWAN was developed by research at the University of Delft in the Netherlands. It can predict the intensity and location of the wave energy. To this end, it considers factors such as wind, seabed characteristic, and the interaction between multiple waves. This picture shows the most power stations that run on wave power. Waveforms are classified into 8 types based on the technology used. Thank you everyone.
So for the CO2 emissions, among the different greenhouse gases emitted by human activities, CO2 released by the burning of fossil fuels is the most important driving cause of increased radiative forcing causing global warming and as a result climate change. In Australia, the energy sector is highly dependent on fossil fuels, the major source for power generation for the economy. In 2012, fossil fuels that include coal, gas, petroleum, and other liquids provided for more than 93% of total energy consumption in the country. The heavy dependence on fossil fuels translate in extremely high per capita emissions of CO2 and has Australia ranked amongst the most pollution-intensive countries in the world. Renewables contributed to 19% of total electricity generation in 2018, specifically hydro 7%, wind 6%, and solar 5%. Currently, Australia's renewable energy markets contribute to 14.9% of total electricity production, with gas and coal supplying approximately 21.9% and 61.2% respectively, whilst contributing to high CO2 emissions. At 293 kilojoules per kilowatt hour and 22.8 grams of CO2 per kilowatt hour, the respective energy and carbon intensities of wave energy converters are comparable with large wind turbines and very low relative to fossil fuel generation. Like wind turbines, the most significant environmental impact arises during manufacturing, material use, and shipping of the wave energy converters rather than through operation and maintenance. Relative to other renewable technologies, carbon intensity for wave energy represented here as pelamis, as you can see on the figure, a commonly used wave energy converter, is significantly lower than that of solar, photovoltaic cells, and slightly higher than that of wind and hydropower.
So, the feasibility in Australia. What are Australia's wave energy resources like? As a potential renewable energy source that could be implemented into Australia, wave energy is a really promising candidate, just based on the strength and consistency of its supply to some of the regions of the continent. So examining specifically for suitability, the southeastern coast of Australia reveals that this resource is really well sustained there, especially over the entirety of the year, as it demonstrates, very little to no seasonal variability, which is something that you do get some of in wind and solar farms. This southeastern coastal shelf also experiences fewer extreme weather events that could potentially end up altering the wave modal climate, just in comparison to other potential sites like particularly the southern part of the continent. Furthermore, this area of the continental shelf experiences a really moderate rate of wave power, so sort of 10 to 20 kilowatts of mechanical power. And with wave energy converters, they generally require sort of that 5 to 30 kilowatts to be operational. So too little, not enough energy generation, too much can often end up causing these systems to perform poorly. They end up with a bit more damage to the equipment, and then they do require more significant downtime. So can wave energy meet our domestic energy demands? Well, it's very unlikely that we will see wave power replace fossil fuels, especially in the near future, as there is a really significant lack of funding for the research and infrastructure, as well as just a lot of political hindrance. So preventing the implementation of more renewable energy sources in general is just something that's happening a lot due to politics. Currently, with 20% of the Australians' total electricity production being produced by renewable sources, there is a really great opportunity to generate higher percentages of the total energy production, especially through wave energy. With modelling studies such as the one included in this slide from this figure, they show that up to, for example, 15% of the total annual electricity could actually be generated by just using that one southeastern shelf site. But what about the environmental impacts of this energy source? Is it truly renewable and safe in comparison to fossil fuels?
Coastal environments are very important marine habitats with high biodiversity. To evaluate the feasibility of wave farms in Australia, it is therefore important to determine if wave energy farms have deleterious impacts on coastal environments. Carter et al. In 2007 described the theoretical environmental impacts of wave energy farms as the following: changes in sediment transport and erosion due to the attenuation of wave energy, the disturbance of aquatic organisms due to wave energy farms emitting electromagnetic fields, and the occurrence of strike injuries to aquatic organisms due to the rotating blades. However, a clear scientific understanding of the environmental impacts of wave energy farms has not yet been obtained. A study in Portugal in 2010 found that the impact of wave energy farms on tides and onshore wave processes was negligible. However, in contrast, a similar study on the same wave energy farms 4 years later found a significant reduction in wave height. With regards to strike injuries and the disturbance of aquatic organisms due to electromagnetic fields, there is little evidence of such events actually occurring. Even if such impacts were common, the consensus seems to be that technology could be employed to mitigate these impacts. Hence, the implementation of wave energy farms in Australia would likely not result in degraded coastal environments, therefore suggesting high feasibility. In conclusion, wave energy presents itself as a suitable alternative to fossil fuels due to its high predictability, low carbon intensity, and low environmental impact. Furthermore, Australia has an abundance of wave energy resources, particularly along the southern coastline and southeastern continental shelf. Whilst wave energy alone may not fully replace fossil fuels, it has the potential to greatly contribute to Australia's renewable energy mix. That concludes our presentation, and we hope you learned a lot about wave energy.